Hello, my name is Jeremy Vickery, and we will be talking in the next couple of hours about efficient cinematic lighting. So when I talk about efficient cinematic lighting, this is what I mean. Efficient meaning working within your budget, getting it done on schedule, which is a big thing. Cinematic meaning having appealing style and telling your story, telling a good story with this. And lighting, the use of lights to aid color and composition in a scene. So putting all three of those together into a potent mix of efficient cinematic lighting. So we're going to talk about a whole bunch of different things. We're going to talk about lighting for illustration. We're going to talk about lighting for animation. We're going to talk about composition, a whole bunch of different topics. We'll see how much I can squeeze into this next couple of hours. But hopefully this will be useful. So I've found that lighting tends to be something, if it's done really well, you don't notice it. And so a lot of times schools focus on lighting, technical side of lighting. If it's live action lighting, they get into the power and the physical electricity. If we're getting into CG, where they're talking about the buttons and the knobs. If you've seen my first DVD that I made, Practical Lighting Color, you'll realize that, that kind of bugs me. There's so many principles of good lighting that you just don't see taught very often in schools. And so I'm going to hit on some of the subjects that I feel strongly about, and hopefully they will be useful to you, and you can see, a little bit into my thoughts with, how to make something that's efficient, fast, and, beautiful. All right, prerequisites for this course. Just like my first DVD, Practical Lighting Color, I'll really try to stay global enough that no matter which software you're using, you'll be able to take the concepts and apply them well. I will be using Maya as my kind of tool of choice, for lighting in this demo, but hopefully this will be able to apply to whatever software. I'm not making this as a technical training DVD, though I'll hit on some technical things and some useful things. But this is about creating artwork and becoming more efficient and cinematic with your lighting. I'll be happy to try to answer some technical questions, but that's not the point of this DVD. I'm sure I will miss some details and I'll make mistakes, but hopefully the meat of the material will be very informative. And the reason why I don't want this to be a just technical training telling you how to use Maya to do lighting is it'll be obsolete in just, a matter of weeks, knowing the way Maya is. In fact, I'm even using an older version of Maya, so, that I'm already out of date with that. So the ideas of how to light a scene creatively and using the tools as well are important. So first thing I want to do with this DVD, let's get into the meat of it. Hopefully many of you that are watching this have already seen my Practical Lighting Color. There's so much in that is kind of like that's the step one. This is step two. If you have not seen it, let's kind of go through some basics. So what I covered in Practical Lighting Color was, what does light do? So very practical, break it down, simplify everything to see what light does. So here's my quick run through. The first thing, light only does three things. It reflects, it refracts, and it's absorbed. Easy if these is absorption, if all the different wavelengths of light kind of coming in, like you've got, blue light, green light, red light, violet, ultraviolet, you're coming into an object. If the object is red, all of the blue and the green and the purple gets absorbed and only the red light reflects. That's absorption. If you have a black object, all the light is absorbed. Okay, then reflection. And again, in the Practical Lighting Color DVD, I go into tons more detail into each of these things with better examples and fun things to look at. But this is just kind of a quick recap. So, specular reflections versus diffuse reflections. So there's two different kinds of reflections. There's light that kind of comes in from one angle, bounces off of a smooth surface, and comes out at an equal and opposite angle. This is like a mirror reflection. That's how light bounces off of surfaces. If the surface is kind of bumpy, you'll get what they call, or what we like to call, a diffused reflection, where the rays no longer come in. You're not going to see a reflection of yourself when you look at a piece of cloth or fabric, but you are going to see light bouncing off and diffusing. going to be kind of a soft reflection. Kind of like this. Sunlight coming from the sky hitting the ground, and you're seeing light kind of in these areas, but it's a soft, diffused reflection. Okay? Then we got shadows. Shadows work the same way. It's just the absence of light, but you've got, and this is something that I talk about but is not really accepted in the scientific sense, but it's really easy to understand. The idea of like specular shadows versus diffused shadows. There's no such thing as a real specular shadow, but the idea of nice crisp shadows and nice soft shadows. This is also in the computer graphics world known as ambient occlusion, where two objects come together and you get this kind of darkening, this contact that allows the objects to feel like they're actually touching. So soft shadows, hard shadows, or diffuse shadows. So diffuse shadow, oops, I copied the wrong image. Like a diffuse shadow versus a soft shadow versus a hard shadow. This is how we can tell in these images, all this information via ambient occlusion, that we can tell the shape and the form of these objects because of the soft shadows and the way the light kind of wraps around. Our eyes already know this. Okay, color. Key things that you should really understand about color before we get into this DVD, the idea of color temperature. Now you'll see this with live action lighting, where you have degrees Kelvin. If you go out and you buy some actual studio lights, there'll be different degrees Kelvin that will tell you the temperature of the light, the basic color. But the main idea of this is to think of light like a light bulb slowly being turned on. So if you have a light bulb, the filament in it, the part that actually glows, when it's off, it's black or gray. And then as you heat it, it will eventually get to red. And as you heat it more, that red will turn to orange, and the orange to yellow, and the yellow to white. If you keep heating it, it'll eventually get into kind of these blue type of tones. That's color temperature. How you apply it, here's a simple example of how I used to think with painting. To go, well, objects are bright red if they're in the sun, and dark red if they're not in the sun, or bright blue versus dark blue. And this sort of works, but it's not accurate to what science really does. A better way to think of it would be, as objects gain temperature, as they gain more energy, the light, it's not only the brightness of the color that changes. So it's not only the dark red, light red, it's dark red and then to orange, and then to yellow, and then to white as it increases in temperature. Same with the blues. So you're not just changing value, you're changing value, hue, and saturation. As things get brighter, they lose saturation and they shift their hue. So they're actually changing color. So you go from this kind of violet color into more kind of teal cyan, and eventually to white, losing all the saturation as it gains energy. Another example really quickly of this is the color picker from Photoshop. You can kind of see this mid-range on a wall from a photograph as proof that this mid color is kind of an orange. And the theory is that as I get brighter, it's going to lose saturation and go more towards yellow. So if I go ahead and select here in this area, you can see the color has shifted more towards yellow and gotten much less saturated, versus up in the corner, it's going more towards red and getting far more saturated. So, practical example again of color temperature in use. And this is again recap from Practical Light and Color. Instead of just painting a cave, one consistent tone like the color of the walls, and thinking of a cave as the color of the cave, think about light. So I'm going to have kind of a cool light from outside shining into the cave. So I have a deep purple, and it's going to shift in hue and saturation. So super saturated purple into a less saturated blue, into a less saturated kind of cyan, and eventually to this very kind of powdery blue. Same with making these crystals glow. I've got kind of this deep purples into reds, into oranges, and then to yellow. And so you get the idea. Color temperature. Relative color also. So I'm focusing kind of this area of the of this character's shirt in this painting. It looks blue, and this is the actual color down here. When I put it in a warm environment, this color relatively is a very cool color, so it appears blue. But if I switch to this scene, now this color appears very warm. If I put that same exact color into a cool environment, it's going to look warm. So it's the same color in both of these paintings. You can kind of see the swatch down here. But the idea of color temperature, or not color temperature, but relative color, colors as they relate to each other. This is very important when you're doing lighting or illustration, because there's times when you want to have a more subtle kind of palette. Instead of choosing a bright blue light, you might choose what this actual color is. It's a desaturated red. So desaturated red can look blue, and it can also look very warm. So the idea of color temperature, relative color. And then there's a few other things with translucency versus transparency, opacity, objects that refract, the way light refracts. So transparent object, light will come in through an object and be bent slightly, like light through glass. And then there's opaque objects, something that light doesn't go through at all, it just kind of bounces off the surface. And then there's the majority of the world that has some level of translucency, where some is bouncing off the top, some is refracting through the center, and a lot of that is actually diffused. So just like you have specular reflections and diffuse reflections, and specular shadows and diffuse shadows, you can also kind of say that you have specular refraction and diffused refraction. So that's applicable when it comes to things like subsurface scattering through skin and through fruit and objects that let some light through, as well as atmosphere. So another powerful tool, and we'll talk about this more later practically, the idea of being able to give distance, this subsurface scattering that's happening in the air itself as the light is refracting off of the molecules in the air and giving us a sense of depth. Same with here, atmosphere and depth. All right, so I'm going to go on now and talk about composition.